Now actually comes the interesting part. And the interesting part is this, that actually any function which we are going to do from now onwards is actually a type of a relation only. A function is actually a relation. But every relation, whatever relations which we have now seen, every relation is not a function. So for a relation, now listen to this thing, now this is the most important thing. Any relation which we have seen, any relation would be called a function. Function is like the next category of relations if they actually fulfill certain conditions. So exactly what are those conditions actually? So a relation would be called a function only if, now actually just listen to this line. A function is a type of relation when every element of set A, a function is a relation, we have done where every element of set A has a unique image in set B. And you can see that I have specifically changed every and unique because they actually signify a not, and we are going to play this thing. So any relation is not a function. A relation can be called a function only if set A has a unique image in set B. Now what does this mean? It means actually the previous examples which we have done of relations, we have seen that connections are of this type. These two words, step by step, first word, every first of all. So we have seen examples in which if a relation is connected between just these two sets A and B, relation is this, that every element of this set, we can see that we have seen in previous examples, the connection between A and B could be of this format, and some element in this set A could be left out. It would be not part of the domain. But now a relation would be called a function if every element of set A is connected. So every element is connected means that every element of this set A should be part of the domain. In a relation, there could be elements which are left out, which are not part of the domain. So relations in which to qualify as a function, every element of set A should have a connection. So let's say if some element of set A is not, then that relation is not a function, that's it. So every should be connected. This is the first condition. And the next condition is this, that connection should be unique. That connection should be unique. What does it mean? That this situation shouldn't arise. Which means that every element is having a unique image. Every element is having a unique image. But let's say some element in this set A is having more than one images. It is elements. It is a one many thing, a one many relation. One element here is connected to more than one elements there. Every element of set A should have a unique image and every element should be having an image. So if this situation is arising where some element in this set A is connected to more than one elements of the set B, then this relation is not a function. So this sums up as that any one many relation would not be a function. Why? Because in one many relation what is happening is that some element in this set A is having more than one connections, more than one images. So the condition is this, that every element should be having an image and that image should be unique. For many one it doesn't matter. Many one is okay. This element is having just this image. This element is also having this image. For this element the image is unique. This element is having more than one images, so that's okay because we are not told that we should be restricting ourselves from this side. Every element should be having an image. Every element should be having an image and that image should be unique. For this element, this is the only image. This is the only connection. So many one is okay. Many one relations are functions. One relations also are functions. But one many relations are not functions. Why? Because for a one many relation, this condition actually is not fulfilled. Every element of set A should have a unique image in set B. Only then a relation would be qualifying as a function. So this is the basic name which we have to understand. So just try to fill up your mind with this basic theory, and we'll deal with many examples right now to make us all understand that what we are talking about. So now let's just implement this logic onto some examples. So in this question we are given this set X and this set Y, and we have been asked whether this relation, this set of relation which has been given to us, whether this relation f1 is a function or not. So we know that the condition is this, that for a relation to be qualifying as a function, every element of the first set should have a unique image in the other set. This is the only definition. You only have to focus upon this word. So in this example, we can see that 1 is connected with 1. 1 from the first set is connected with 1 from the second set. 1, 2, 3, 4 are here, and 1, 5, 9, 11, 15 and 16 are here. So for this relation to be a function, only condition is this, that every element of the first set, set A, should have a unique image in set B. So in this example, we can connected with this 1. This 2 is connected with this 11. This 3 is connected with this 1. This 4 is connected with this. So what kind of relation is this? First of all, we can see that every element of set A has an image in set B. So the first part is fulfilled. And for every element, the image should be unique. The image of this 1 is this 1. So it's a unique image. The image of this 2 is 11. The image of this 3 is 1, which is okay. Why? Because the image of 3 is 1. Don't get confused that 1 is having two pre-images. This is not to be confused. 3 is having just one image. 3 is having one image. 1 is also having one image. So every element of this set is having a, hence this set which is given to us is a function. This is a function. Why? Because every element of set A is having a unique image in set B. So the complete condition is fulfilled here. So this given set over here of a relation is actually a function. So now I'm moving to the second example. Just try to actually answer it by yourself while I'm solving it. Just now let's all have a look at the next example. So now in this question, we are given this set X and set Y, just like the previous question, and we are given this relation. So 1 is connected with 1, 2 is connected with 9, and 3 is connected with 5. So 1 is connected with 1 here, 2 is connected with 9, and 3 is connected with 5. So the question is, just try to answer it by yourself, whether this relation is a function or not. So we can directly see that this is not a function. This is not a function. Why? Because the condition is this, that every element of the set A should be having an image. And in this case, we can see that this element 4 is not having any image in the other set. Is not a function because the condition is not fulfilled. So now let's just see one more example to just complete this point well. Let's have a look at the other one now. Again, a similar kind of example. We are given the same set X and same set Y. Now the relation defined is this. So this 2 is connected to 9. This 3 is connected to 1. 4 to 5. And 2 to 11. 2 is connected to 11. Now here's the problem. 2 was already connected to 9. Now 2 is also connected to 11. This creates a one-many relation. This creates a one-many relation. We are not worried about many one, because many one in many one, every element is having a unique image. 1 many creates a trouble. Now this element 2 is having two images, two connections in the other set. So every element of this set should be having a unique image. We were not worried with any other case, because for any other case we were not facing this trouble. Now this is the trouble. This is a many one relation. This is a one many relation, and one many relations this is the line which you have to just keep this, exactly this line in your mind, that one many relations are not functions. One many relations are not functions. So this is a one many relation. So this is not a function. This is not a function. So you just have to, the motive of today's class was to actually make you reach this level, that we should be able to differentiate that this relation is a function and why this relation is a function and why the other one is not a function. So this was the basic motive of today's class. So just have a look at whatever we have done in today's class, just revise it well, and in the next class we'll start with how to actually look at it graphically, how we can clearly graphically identify whether a given relation is a function or not, because that would be the question that we will be facing ultimately in exams. But the important part was to understand this logic first of all. Okay, take care, bye, all the best.